Okay. Good morning, good morning, good morning. How's everybody doing? All right, great. Um, So welcome to the 20th Annual Public Meeting on the long-term plan for achieving water quality goals in the Everglades Protection Area tributary basins. Now, I've been practicing that for several weeks now, and it's just a mouthful, but so I want to welcome everybody. I think this is going to be a very informative meeting. I'm Robert Shuford. I'll facilitate the meetings. And this annual meeting is primarily established not just to disseminate information in and around the district, but is actually designed to address stakeholders, the public, to make sure that they're aware of the progress that we're making toward achieving good water quality inflows for the Everglades. We'll hear a lot about restoration strategies today, and that's actually the enhancement of the long-term plan that was mandated in 2003. We'll talk a little more about that shortly. One of the first things I want to do is just, I know everyone here is pretty familiar with the district, but if there is, anyone who is not, just through the doors to the left here, we have the cafeteria, restrooms, water fountains, vending machines. The only thing we ask is that you don't bring food into the auditorium, okay? All right, so let's get right into it. Today's presentations, there are 7 presentations. They'll be followed by public comment. So if there is an interest for public comment, there are public comment cards at the sign-in table out front. For those who are on the media, on Zoom or YouTube, or if you would just, at the time, raise your hands, we will actually acknowledge you so that you'll have an opportunity to share your public comment with us. If there is an area of particular interest, or if there is, a specific question that you have, we ask that you contact the presenter. The presenter's information will appear on the final slide of their presentations. All right, so since I am the first presenter, we'll get right into talking about systems, the system conditions. So, like I said, you're going to hear a lot about restoration strategies today. This is our state's plan for constructing, expanding, and improving our system of stormwater treatment areas, known as STAs, and the flow equalization basins, known as FEBs, which are located in the, give me just a second. They're located in this area called the Everglades Agricultural Area, or the EAA Basin. So restoration strategies was comprised of 13 projects to be completed over a 13-year period. In this map, it shows the restoration strategies that are conducted in or among or around the 5 STAs that are highlighted in red, and the construction of 3 FEBs, which are shaded in blue. To date, we have 10 projects that have been completed. We've got 3 projects left, so the end is approaching. In addition to the restoration strategies projects, we have gone above and beyond those requirements to do further enhancements that improves our water quality capabilities. They're known as refurbishments, and you'll hear about those today as well. All right, to make sure everybody is actually on the same page with regard to water year, because some of the data that will be presented will be presented as seasonal or within a water year. Just want to make sure everybody is apprised of what that means. A water year runs from May 1st to April 30th. It's partitioned into two seasons, a wet season that occurs from May to October, and a dry season that runs from November to April. So understanding that, we'll kind of move right into the rainfall of the system. All right, so what I'm going to present is, we'll start at dry season 2022 to sort of give us an idea of the start, the conditions at the starting point as we approach water year 2023. Okay, so what we have here, this is the dry season rainfall for water year 2022, the previous water year. In this graph and the subsequent graphs, you'll see a large graph to the left. This graph shows the volume of rainfall in inches for the dry season period. In this case, because this scale will likely change over the next few slides, but in this case, the dark blues to blue is 0 to 15 inches of rain. The light green represents the light greens to oranges. Light orange represents the modest rain, 15 to 20 inches, and then the dark orange and red, almost deep purple, represents 20 to 30 inches, and that's within a dry season period. So the smaller graphs that you see to the right are monthly percentages of normal for that month, rainfall percentages. And that scale pretty much runs on all of the ones I'll show. They run from less than 30% of normal to over 300% as the light purple of normal. And we'll pretty much be operating in the light orange, the oranges to greens for the most part. So in dry season 2022, it was a near normal year. It was actually about 84% of normal. And it was I'm sorry. So 84% of normal for the year. It started with a very wet November. The November rainfall sort of set the stage for the wet season. You started out wet, and we had that continuing drying trend right through to the onset of the wet season. The areas that we were interested in, or are interested in, falls within this boundary. And you'll see that for the most part, throughout the dry season of 2022, it was a pretty dry year in the C139, EAA, and C51 basins. We also experienced a major drying trend between December of 2021 right through to March 2022. I'm sorry, December 2021 to March of 2022. In the wet season that started in May of 2022, we have, again, the same layout, but in this case, the dark blues to light green, so this range is between 20 and 30 inches of rain. And of course, at the very top, the yellows to the reds is 50 to 80 inches of rain. So obviously, wet season, more rain. During this wet period, our maximum rainfall was over here on the southwest coast. And the maximum rain that fell in that region was about 64 inches during that season. May and June produced normal rains throughout the district. But then we went into a drying trend in July and August. And this is not atypical. We do have a decline in the amount of rain that typically falls in July and August. But then we quickly rebounded with heavy rains in September of that year, in part due to Hurricane Ian, followed by a very dry October. And this slide represents dry season 2023. So that's the period of time that we're in currently. And this graph, the scale, again, is slightly different, but this represents a partial year. And it ranges from pretty much from the purple to dark blues. It's about 6 to 10 inches of rain. And then, of course, our max ranges are in the oranges to reds, which is about 20 to 25 inches of rain. Now, this map represents up to the first week of February of this year, and our maximum rainfall was about 25 inches. The dry season was near normal. It's been pretty much near normal district-wide. And again, we had November, a wet November, especially in the Kissimmee Valley and the East Coast, in part due to Hurricane Nicole. And I'll talk about that in the next slide. January and February have been extremely dry conditions. So we had 3 major rain events this water year. We had a potential tropical cyclone, number 1, that happened in June, very early in the wet season of this year, June 4th. Then we had Hurricane Ian that occurred in September, late September of this past late September. And then this past November, we had Hurricane Nicole, and you saw some of the responses in the rainfall previously. Nicole actually produced about, for the month of November, which was really wet, it was 169% of normal, a fair amount of rain. Hurricane Ian, the month of September, resulted in 185% of normal. So it was a fair amount of rain that was dropped in those storms. And not to exclude PTC1, that actually resulted in about 119% of normal. All right, so we've seen the rainfall. We've talked a little bit about the storms. Let's look at how that actually impacts the system. So the next 2 slides, we'll be looking at the marshes that's north of the EAA and south of the EAA. So we'll start with Lake Okeechobee. And this graph and the next graph, you'll see 3 boxes. These boxes represent the dry season, wet season, and dry season of the period that we're discussing. So as we start the dry season of 2022, we were, Lake Okeechobee stage was near the intermediate band. And of course, going into dry season, we have this gradual decline until right after the start of wet season. So in other words, we had a late, sort of a late wet season that started somewhere around the 16th of May. The system responded to a few weeks later when we had tropical storm or potential tropical cyclone 1. We got rains that gave us a little bit of reversal, but it was kind of a modest response that continued until September. In September, we dropped down below or dropped into the intermediate subband. And then shortly after, of course, Hurricane Ian, and we got some reversals. So Hurricane Ian coupled with moving water from the Kissimmee Valley pushed the lake levels back up. And those increases continued right into the start of the dry season when we experienced Hurricane Nicole. Nicole had a modest response, but it literally helped to keep the water levels well above or above the intermediate subband through a large portion of the the dry season, I'm sorry, dry season 2023. On the southern end of the system, Conservation Area 3A, we see a similar trend. We have the rains from November of 2021, the gradual decline during the dry season into the wet season, and shortly after the start of the wet season, we see PTC1. We see a modest increase or modest response. Drying trends coupled with moving water to across the Tamiami Trail in July and August, resulted in a decline in 3A. But then we experienced Hurricane Ian, and Hurricane Ian helped to restore levels above schedule. And that persisted right through the end of the wet season into the dry season, and of course, Nicole, we see the impact of Nicole. Not a major impact, but there was, a slight response. Now, the EAA is bounded, of course, like I said, on north, Lake Okeechobee, south is 3A, but to the east are Conservation Areas 1, which is the Loxahatchee National Wildlife Refuge, and Conservation Area 2A. So this slide, and not going to spend a lot of time on it, but it's basically just to show that there was a similar pattern. I didn't put the seasonal breakdown, but a similar pattern. We get rains, we get increases, and that's the story on this one. All right, so we've looked at rain. We've kind of looked at how the system responds to the rain. Now we're going to look at seasonal inflows to the STAs. So here we have 3 seasons: dry season 22, wet season 23, and dry season 2023. And what we have here, the blue bars are runoff to the STAs, and the yellow bars are lake release or regulatory releases to the STAs. And then, of course, the rainfall is located at the bottom of the graph, and this represents basin rainfall for the region. What we see is STAs received about 255,000 acre-feet of inflows during the dry season of 2022. That volume was partitioned into about just under 210,000 acre-feet of runoff and about 47,000 acre-feet of lake releases. And this all is kind of a response in part to almost 10 inches of rain that was experienced in that dry season period. In water year 2023, the wet season, we experienced about a total of about 1 million acre-feet of inflows, and of that, 975,000 was of runoff, about 12,000 was lake release. And this all responded to almost 40 inches of rainfall during that wet season. And then finally, in the dry season, the current dry season that we're in, we've already experienced about 127,000 acres of inflows, of which 114 is due to runoff, and about almost 13,000 is due to lake releases. We've experienced about 3.5 inches for this dry season. All right, now this last slide I'm gonna present, it's actually looking at 3 water years, and it sort of transitions well for the next presenter because there'll be data presented on this scale. And so, again, the blue bars are runoff, yellow represents lake water, and the green represents the basin rainfall. And you see in 2021, water year 2021, we had about 1,600,000 acre feet of water, which is one of the highest experiences we've had since the inception of the STAs of inflows. And of that, about 1.4 million of it is runoff. 162,000 is from the lake releases. In 2021 water year, we had about 58 inches of rain that fell. Makes it somewhere between the upper end of normal, or just on the lower end of a wet year. In 2022, again, we have about 1 million acre feet that went into the system, 918,000 that was runoff, and 108,000 that was from the lake. Again, we was responding to about 47 inches of rain in the basin. And then finally, in 2023 wet year, the current wet year we're in, and again, this is partial because we have about 3 months left before it's closed, and we had right about 975,000 acre feet of runoff to about 25,000 acre feet of lake releases. And we have, so far, we've had about 46 inches of rainfall in the basin. All right? So that's kind of just a quick overview of the system in and of itself, sort of where we were, where we started, and where we are now. So this next presentation, we're going to hear about the performance of these STAs. That presentation is going to come from Mr. Jake Dombrowski. He's a senior scientist in the Applied Sciences Bureau, and we'll yield the floor to Mr. Dombrowski. Right.
All right. Good morning, everyone. So as Robert mentioned, I'm Jake Dombrowski. I'm an environmental scientist in the Water Quality Treatment Technology section of the Applied Sciences Bureau. So today I'll be giving an update on the performance of the Everglades stormwater treatment areas. So this presentation is primarily going to focus on the performance for each of the 5 STAs. They're on this map here, similar to Robert's in the kind of medium green color. So for performance, we're going to be looking at flow volumes, TP loads, and the flow weighted mean concentration. So I might just refer to concentration at a few points, but I'm always referring back to the flow weighted mean. So we're going to look at yearly and monthly variation, as well as construction and other operational restrictions. So starting off with STA1 East, a lot of these slides are going to look very similar, so spend an extra second here to orient you. The chart at the top is concentrations, so inflow concentrations in red and outflows in blue. And then they also have these black dots, which indicate the percent reduction from in to out. Going to focus on the same water years as what Robert displayed. So water years 21, 22, and partial 23. So since we haven't completed 23 yet, I only included data from or through December 31st, and it includes provisional and preliminary data. Some of the same information is in the table below. The table also includes inflow volumes, TP loads, and percent reductions as well. All right, so for 1 East, so far in water year 23, we've had less inflow volumes coming into 1 East. I'm going to touch on that in a couple of slides. The inflow and outflow concentrations are relatively similar to last year, although both those years are a little bit lower than water year 21. And then the percent reductions for 1 East remain similar to previous years. So moving on to monthly trends. So these slides are going to show the TP concentrations in the chart at the top. So inflow still in red, outflow still in blue. Center graphic is TP loads, and then the bottom one is flow volumes in 1,000 acre feet. So for 1 East, we've seen lower inflow volumes relative to previous years. So that is primarily related to the construction that has been ongoing there. I'm going to give some more details on that in the next slide. We also, as Robert mentioned, we've had an active storm season, so you would expect to see higher inflow volumes here, but thanks to the L8 FEB, captured a lot of those peak stormwater flows in September, so there wasn't as big of an impact on 1 East. One last trend to point out here, the outflow concentration for 1 East has been fairly stable and in the low range for a couple of years now, and had minimal impact from the hurricanes. Moving on to operational restrictions. So these slides are going to be for the previous calendar year, so calendar year 22. They're going to include construction, vegetation management activities, bird nesting, those types of things that impact our ability to fully operate STAs. So for 1 East, the Western Flowway has been offline for a couple of years. This was an earthwork project in cells 5 and 7 and some work in cell 6. So that project is now complete and is undergoing vegetation grow-in, so trying to reestablish a lot of that wetland vegetation where the construction happened. The Eastern Flowway is also offline for a portion of this year. This was to repair some damage that was caused during Tropical Storm Eta back in November 21. And then we also had periodic restrictions in the Central Flowway for vegetation management and blackneck stilt nesting. So photo on the bottom left here shows some of the completed work in cell 7 with some wetland vegetation starting to come back in. And then the photo on the right is one of the blackneck stilts that was protecting some of its young in 1 East. All right, moving on to 1 West. So far in water year 23, 1 West has had higher inflow volumes relative to previous years. The inflow concentration for 23 is also higher as well compared to water year 22, but both water years 22 and 23 are lower than 21, which was a near record year, as Robert mentioned. The other thing I should point out here, the outflow concentration. So STA1 West's outflow concentration has been much lower this year, and the percent reduction in both TP load and TP concentration has been higher. Looking at the monthly trends, so far in water year 23, 1 West has received higher inflow volumes. This is related to a couple things. So there's been a few refurbishments projects that have recently wrapped up in 1 West, improving its capacity to take flows. And then all the work ongoing in STA1 East has led to water being channeled towards 1 West instead. One last thing to highlight here for the monthly trends is the outflow concentration in water year 23. It's been low and stable with minimal impact from the storm season, thanks to the L8 FEB. For operational restrictions, 1 West, all the flowways were online this year. However, there were periodic restrictions in each of them. So those were refurbishment earthwork projects that occurred in the northern, western, and eastern flowways. These were primarily levee reconfigurations. So the photo on the bottom right here highlights this kind of like L-shaped open water area is where a levee used to be, and it's currently being revegetated, and while the levee was moved elsewhere. There was also construction related to expansion number 2 in cell 8, and we had blackneck stilts nesting in the northern and eastern flowway. For STA2, so STA2 has had relatively similar inflow volumes compared to last year, or at least it's on track to be about the same as last year. The inflow concentrations and the outflow concentrations have been higher this year, especially for the inflows, and I'm going to touch on that in the upcoming slides. The percent reduction for STA2 has been down, while the amount of TP load retained within the STA has been relatively similar to past years. For monthly trends, there's been elevated flows and TP loads at a few points in the past, or in water year 23. So Robert touched on the potential tropical cyclone 1 that occurred in June. So you see this large influx of water there, and then Hurricane Ian in September 22. So both of these events brought high inflow volumes to the STA, at least for the monthly time step. The A1 FEB helped to keep these inflow volumes down. The FEB captured a lot of these peak flows, but the STA did still receive quite a bit of inflows during those months. Other thing to highlight here, the concentrations at the in and out. So in 23, we've had these higher inflow concentrations, and then we've seen a slight uptick in the outflow concentration as well. And that's related to a couple of factors. I'm going to transition to the next slide. So for operational restrictions, Flowway 2 of STA2 has been offline for a number of years. This is for an earthwork project to level out the inflow areas. And the photo on the bottom left here highlights. So this was just after a lot of the earthwork was done. You could see some vegetation starting to come in, and then this is what it's starting to look more like now that it's been rehydrated and there's some actual wetland plants being introduced. So this work that was going on in Flowway 2 required very low stages for the construction, which impacted Flowway 1. So Flowway 1's directly adjacent, and a lot of the stages there were reduced while the construction was happening. This actually caused dry out for a number of months this past spring. So that combined effect of reduced capacity in Flowway 2 and dry out in Flowway 1 are likely big factors for the uptick in the outflow concentration. Back to operational restrictions, we did have periodic restrictions in Flowways 1, 3, and 4. These were primarily related to vegetation management activities. Then we also had blackneck stilt nesting in Flowways 2 and 3. And I'd be remiss not to highlight our tropical visitors that we saw again in Flowway 3 this year. All right, STA 3.4. So 3.4 has had similar inflow volumes compared to last year, or at least it's on track to. The inflow concentrations and the outflow concentrations remain relatively similar across these 3 years, while the percent reductions in both TP load and TP concentration remain relatively similar as well. For monthly trends, the biggest thing to highlight for 3.4 is the reduced variability for the inflow and the outflow concentrations. So this is largely a big benefit of the A1 FEB. STA 3.4 is directly adjacent, so it receives a lot of the benefit there. Other trends to point out, we had elevated flows and loads similar to STA2. So June 22, that potential tropical cyclone, and then September was Hurricane Ian. And again, we had high inflow volumes coming to STA 3.4, but the A1 FEB definitely assisted and kept those numbers lower than they could have been. For operational restrictions, the eastern flowway of STA 3.4 has been offline for a year or two now. This is for a vegetation rehab project that's been ongoing. So this is a managed drawdown to try to improve the emergent vegetation communities there. This photo on the right, it's a little hard to see, but there's thousands of little green dots that are fresh plantings of emergent plants there. The central flowway also had blackneck stilt nesting that occurred this year as well, and photo in the center here highlights one of those nests. All right, on to STA 5.6. So inflow volumes for 5.6 have been kind of in between the past couple of years, so lower than water year 22, but higher than water year 21. The inflow concentration, however, has been much higher in 23, and the outflow concentration has been trending downwards. So in this year, the outflow concentration is quite a bit lower than the previous years. The percent or the amount of TP load retained in the STA has been higher, and the percent reduction in both load and concentration have been up as well. Looking at the monthly trends, we had a few TP load and concentration spikes for 5.6. These were largely related to the hurricanes that occurred, so Ian and Nicole. The other thing to point out for 5.6 is the frequent dryout conditions. So the C-139 basin that 5.6 receives runoff from typically runs a little bit drier than the rest of the EAA. So between the months of typically like February to May or so, we see dryout conditions out in 5.6. This has negative connotations for the concentrations. So following the dryout conditions, we see elevated inflow and outflow concentrations. However, in water year 23, it's been not as big of an impact, and the outflow concentration has been relatively stable even with the active storm season. One last thing to point out for 5.6.2 is I actually had to adjust the scale, the y-axis here, because 5.6 has been receiving such high inflow concentrations. In terms of operational restrictions, there really hasn't been much out in 5.6. Flowway 4 was offline for a portion of time for vegetation management. Otherwise, all other flowways were operational. So I wanted to highlight a few other things here. A number of years ago, we had some earthwork that was done in flowways 2 and 3 to improve some of the inflow treatment areas there. These areas have been filling in really nicely. So the photo on the left is cell 3A with some great emergent vegetation communities coming in. And then the photo on the right is just from last week, actually, of some great mixed marsh communities in cell 2B. All right, final slide, kind of a summary for all of the STAs. So the charts at the top highlight each of the 3 water years with each STA being represented. The table at the bottom includes all data for the STAs combined for each water year. So far in water year 23, the volumes have been slightly lower than previous years, although on track to be similar to water year 22. The inflow concentrations have been quite a bit higher than both these past years, while the outflow concentration remains relatively similar, producing pretty similar, if not a little bit higher, percent reduction in TP load and concentration. One last thing to highlight, looking at a few of the STAs, so STAs 1 East, 1 West, and 5.6, they've had a declining trend in their outflow concentrations over these 3 years, so going from left to right. All right, that is it for me. My contact information is listed here if you have any questions, and I'll yield it back to Robert.
Okay. The next presentation is actually going to be on vegetation management. It's coming from Mr. Eric Crawford. He's a senior scientist with the Land Resources Bureau, and I'll yield the floor to you. You need a pointer? Do you need a pointer?
Yeah, I might use it a couple times. Thanks. Morning. Now we're going to talk about vegetation management. A little bit of a switch, less graphs, more pictures. Try and get through this quickly. So the objective of the vegetation management in the STAs is to maintain the phosphorus uptake processes. Most of these are based on the plants. Some are based on the geology, and some are based on the algae and diatoms. So we really try to establish and maintain good native vegetation communities that are stable. And we try to include different species and layer and mix the species to have functional redundancy. We have to do a lot of selective management to do this. We have to plant some species, seed some, and we have to remove a lot of invasives and undesirable plants. This is Florida, and everything wants to grow here. So we get a real heavy invasive species input and growth that can be difficult to control, especially in a newer STA or an STA that's been damaged. So the function of the vegetation in the STAs, the first function of the emergent vegetation is to stabilize the soils. Without the vegetation there, the soils move, and we get erosion, and we just get immediate gullying and short circuiting. So stabilizing the soils, to us is the first function. It's what has to happen before you can move into the rest. So once we get the soil stabilized, then the plants serve to break up the flows, disperse the energy, which can cause a decrease in turbidity and increase sedimentation. We're dropping the particulates out, and those emergent plants are creating litter, and you get a lot of microbial litter and phosphorus uptake capability on the litter. The submerged vegetation, most of the species provide little soil stability, but some do. Primarily, they provide a route of water column and phosphorus uptake. And they also provide a substrate for periphyton to grow on, which can do a lot of phosphorus uptake as well. So the slide shows healthy emergent vegetation in a cell. So the bigger picture shows an early picture of establishment. You can see some cattail, there's bulrush plantings, there's some thalia. We've gone in, removed the exotics and planted these species in there. And then the inset here shows what it's headed for, because this is the inflow cell. So what we want is a cattail-dominated inflow cell. And to get good cattail domination, especially in a cell or a part of a cell with a lot of organic soils, you need the bulrush and the deeper rooted plants to stabilize the cattail. Cattail grows quickly, makes a lot of litter, it does its job really well. Cattail is not stable, doesn't root deeply, and can have a lot of problems with water level fluctuations, with it separating from the soil. It's very buoyant. So we mix in deeper rooted plants. So when you see a cattail stand like that, even if you don't see the other plants, because they may be 2, 3, 5% of the total population, they're doing their job and helping to hold the cattail down. Highly stressed emergent vegetation can look similar superficially, but if you notice, there's a lot of mixed species in there. A lot of them are exotic. In this picture, those soils have delaminated, so a lot of that cattail is floating. So when you have a floating emergent wetland, now you're not getting sedimentation. You're actually dropping soils down into the water column because the bottom is now floating. So they're no longer functional, and they're mobile. And when they're mobile, they can break and stress out adjacent healthy communities. They can ride them down and kill them, or they can clog structures and cause issues with operations. So this is something that has to be removed and stabilized somehow. So we generally break down our species into desirable and undesirable plants. Typically, our desirable plants are all going to be native species, and they're all going to be wetland species. The undesirables, some are native, many are exotic, some are upland plants. But in a desirable community, we have strong emergent conditions here. Scattered emergent plants helping to stabilize the SAV, and good SAV communities in between. Over here, you have another set of, there's floating cattails, you have invasive species and on top of delaminated soils. You can see the pressure waves from that stuff moving. It can move by wind or it can move by water. So sometimes you'll see large rafts of soil moving upstream. Because if they have a lot of invasive plants on them, they catch the wind. And so the wind tends to be more powerful in the motion of these floating wetlands than the water flows do. So it's hard to predict where they're gonna go and how they're gonna move. So it's easier to remove them instead of try to stabilize them. But when we can stabilize them, we do, because removal is expensive, and then we have an empty zone. And then we have to plant the empty zone. Planting looks like that. We have crews of 15 planters, and we'll typically have 2 alligator removal watchers with each crew, keeping them protected. And they spend a day harvesting plants. We grow our own plants, so we grow harvest sites. We pick species that we like. We pick communities that we like to grow differently. And so they'll spend a day harvesting and then a day planting. Most of our crews do about 5,000 plants a day. And this area is the same area that I showed in the previous slide, with all the floating soils and the floating wetlands and the invasive plants. It's been cleaned out. We removed everything, sank all the materials, and then the crew is going in and planting. In this case, it's giant bulrush. It's a really organic zone, and so we needed a deep rooting plant to go in and stabilize it. There's enough remnant, well-rooted, strong cattail in the area that hopefully once the bulrush stabilizes those soils, the cattail can recolonize. Floating aquatic plants are a big problem, and when the floating veg moves in, it comes in on the water as we have our flows. So when you have a hurricane flow, you bring in a lot of floating invasive plants. When you have a projected hurricane or storm, we move in a lot of floating invasive plants. You don't have to have the storm to get the plants, because surrounding landowners and the farmers will drain their fields in anticipation of the storm, which causes a flow. So we need to protect the plants in the SDAs from these floating plants. When they move, especially in large rafts, they can come in 15, 20 to 100 acres at a time, and they're mobile. And when they go over the emergent plants, they can knock cattail down, and when they go over the emergent or the submerged plants, they can uproot it, or they can just shade it out and kill it. So removing the mobile FAV is our biggest priority. It's what we spend the most of our time doing, chasing it, looking for it, and getting crews out after it. In attempts to remediate the effects of the floating aquatic vegetation, we plant dense emergent strips of them in the inflow regions. Sometimes we can shape them based on the underlying geology, because the cells are not all flat and level. So we plant herbicide-resistant and strong, well-rooted, flow-resistant plants in the inflow areas, and they can hold back and capture some of that FAV and hold it till we can treat it. So it gives us a little buffer in time. When the emergent strips get broken, the planting crews have to go in and plant, and we need to fix them. Otherwise, the water and the FAV finds its way deeper into the cell. And the more we can reduce penetration deeper into the cell, the less these things will affect performance. We need to do most of our work and treatment, we want to keep it in the inflow region, and try not to let this stuff move down through the cell. The closer to the inflow we can control it, the more impact we have. So able to do these processes, we need to watch and monitor the health of the vegetation. Every cell gets inspected from the ground weekly and gets inspected from the air monthly. And typically we'll get a boat in it when something is seen, or we'll go out and walk it. Most of the emergent cells you can go out on foot and do. And inspections. We work with the water managers when we have areas where we see there's been a lot of erosion or channeling or flow, and when there has to be a planting done, and they can help reduce flow rates so that we can get the plantings in and get them rooted and ready for flow again. To proactively manage the vegetation, it typically just involves increasing the cover and health of the desired species. We tend to pick the weakest areas first, and depending on the season, decides the site, the soil, the species. Obviously in the dry season, we will work in deeper areas. Wet season, we'll work in shallower areas. Dry season, we work the inflow regions where there's going to be less flow impact on the new plants. And in the wet season, when flows are coming, we move downstream and plant in more protected areas. So we move around the crews as conditions allow. And there's always repairs to do. So no matter how nicely they plant a nice strip for us, things get broke, they get mashed down, and they need to get repaired. A lot of times an FAV raft can come through, and we've had, I think the worst I had was I lost 400 acres of recent plantings in one weekend. So a bad wind, a bad storm can do some damage. So emergent plant rehabilitation, here's another really ugly delaminated soils, floating wetlands, mix of invasive species, there's a little bit of native species left. There's some healthy cattail on the periphery, but pretty much through the middle, this is all mobile. It's all floating. And, there's the crews on the ground by foot, one plant at a time, harvesting and planting it in. Sometimes extreme measures are needed. In SDA 3.4 cells 1A and 2A, the amount of delaminated soils and floating vegetation started to become dominant and took over large parts of the cell. I worked with a couple of companies. We developed a method by putting a hydraulically powered it's basically a rototiller, but one that can work submerged. And we put it on the end of a floating excavator. This is a huge machine, but it has about a little less than 20 pounds per foot of pressure on the soil, just because it's so wide. You can't see the width in this picture, but this floats on the water, so he can float it and drive it on the water out to the floating wetlands. And when they get there, the grinder goes in, we grind up all this floating cattail and floating invasives, and we grind up the floating soils that are held together with the root masses. And by debulking them and oxidizing them with the grinding, they sink and decomposition starts. And the idea is to put all that material down on the bottom and then get new plantings on top of it to lock it up and consolidate it. Because as long as it's floating, it's mobile. And as long as it's mobile, we're not getting performance, and it's damaging surrounding plants. So this is where we did that, and in 1A was the first time we had to do the extreme grinding. And I've got a little video here that'll show, you can see the dates up in the corner. So this is 2017. SDA 3.4 has a number of short circuits cut in at each structure. This is a large slough that comes down. It's a little bit deeper area with a hard packed marl bottom with a thin layer of floating peat on it. And it flows all the way to the outflow here, and then it splits and does the same over here. This is cell 2B, which is a beautiful, healthy, productive cell with great performance. But at one point in this project, we actually had the bright green here. I played with the imagery to make different species show, and in these settings, it makes the water lettuce and the floating vegetation really bright. And I'll just start the video now. So you can see the progression. Maybe. Should go. So things are getting worse and worse and worse. And it made it to the outflows. You can see it disappear at times. Those are when we've gone in and treated and removed it, and then it flows right back in. And here's where restoration starts. And there's a lot to see, that's 3,000 acres, so there's a lot to focus on. But we stopped the flows, drew it down, grinded up those soils, sank it, and there's the most recent there. So we've established emergent soils in the majority of the cell. Hopefully, we'll keep the stages low until this coming wet season, and then we'll let it come back up, and hopefully we can keep it stable. All right, so in addition to rehabbing the emergent vegetation, we rehab the SAV. That's in some ways easier and in some ways harder. We have to go out into deeper areas. They're collected by hand and then stacked on an airboat, brought to the shore, loaded on a trailer, moved to the target cell. We'll do it within a single cell when possible. But when a cell has had serious SAV losses, we try to bring in multiple species and multiple communities of the same species from different locations. And then we try to harvest from the most diverse areas to bring it in. And, when we see dense chara beds, the chara is a beautiful performer, but its senescence is not predictable. And when chara has been healthy for a long time and the beds die out, it's very difficult to get anything to grow in the soils in the flock that's left behind by a productive, healthy chara bed. We found some species that can grow in those conditions, and so we tend to inoculate them into healthy chara beds just to prepare for the next successional event. So in addition to moving plants around and mixing species and adjusting the communities, we've found that SAV by itself is not very stable, and it's sensitive to a lot of environmental perturbations, to wind, to flows, and to wildlife. So we compartmentalize the SAV with emergent vegetation strips, and sometimes we mix emergent vegetation right in with the SAV. That provides some stability. The roots of the emergent plants hold the SAV, distribute, stop the flows, and protect it from storm events. And when sized properly, a storm event can come over and, the SAV will persist. Without the emergence, sometimes the SAV beds can roll over and they can get blown to the sides, and it takes a long time to recover from that. So we want to avoid that when possible by trying to manage the amount of EAV in the SAV beds or the size of the SAV beds. This is SDA2, cell 3. Had a lot of SAV die-off, had a lot of issues with damage to SAV. The compartments were really large. They were really affected by wind and storm actions. So we had to go into cell 3, and we've planted, well, at this point, I think it's like 12 miles or 13 miles of emergent vegetation strips of giant bulrush, closed off a number of short circuits. Construction was done inside the cell during during the wet. They went in, there's a lot of remnant levees and canals in there, and some of those were degraded, trying to balance the flows and spread the flows out and get an even flow pattern through the cell. Once the emergent plants were stable, SAV was inoculated. And during the establishment of the emergent plants, we also inoculate with SAV. One of the methods that we've come up with to keep our EAV plants healthy, especially when they have to be moved between cells, is as the plants are bundled and collected and harvested from our harvest sites, we wrap the root balls in SAV. So all emergent plantings are moved with an SAV planting as well. So hopefully that's not a lot, but it just takes a few plants to get going, really, to spread throughout the compartment. So here's another video. This one will show, it's from 2017 to December. Was the most recent picture I was able to get. You'll be able to see the short circuiting and the flows through the cell. North is to your left, so it'll be flowing. I had to put it sideways just because of the shape of the cell to show it. But you can see the turbidity from the inflows. You can see how large these compartments are and then how affected they can be. And then over time, you can see the changes through the years. The dates, sorry, they're here and sideways, but you can see as the time progresses, seasonal changes and changes in turbidity. Sorry, and then the planting strips start, and they start to fill in. And when you see the big white areas at the downstream end of a cell, that's not necessarily something bad. A lot of times that means the Cara was growing so well that it really topped out, and then we may have stage changes. So it can be, even in the wet season, the Cara can just fill up. If we have a storm event, stages come up a foot or so, the Cara will follow the water surface up, and then when the water goes back down to target, the top of the Cara gets bleached off. And so a lot of times on the imagery, you'll see these white zones that look bad, but it's just a thin layer of dead Cara sitting on top of a nice bed, and they typically disappear by the next storm. And that'll wind it up.
Thanks, Eric. That was a great presentation. Definitely educational. The next presentation will be done by Dr. Tom James. Dr. James is a principal scientist with the Applied Science Bureau, and he will talk about the status of restoration strategy science plan studies.
Let's do this. Good morning. So I'm the coordinator for the Restoration Strategy Science Plan. I think of myself more as a shepherd. I've been herding cats for the past 4 years now. And I'm going to present to you the status today of the science plan. There are a couple of slides that I will begin with that are consistent from year to year to give you some focus of what's going on. What I want to do first is to acknowledge the fact that these particular studies that I'm going to present, there are 21 that we've done so far in the past 10 years, have involved 4 different consultant firms, 3 universities, and the staff of the district. That includes dozens of scientists, engineers, technicians, lab and field technicians, as well as the administrators. So I do want to say that I'm the messenger today, and they have the answers. If you have any questions, I can make sure that I get the proper person to be to answer those. So I do also want to mention the fact that, we've got each one of these studies could be discussed for hours. So to synthesize it and to summarize it in 20 minutes, it's not going to happen. So I'm going to be as quick with this and just gloss over a lot of material. But I do want to let you know that we're going to have a big presence at the Greater Everglades Ecosystem Restoration Conference, April 17th to 20th. We'll include 29 presentations there dealing with stormwater treatment areas and research. And we're also preparing a special issue of the journal Ecological Engineering dealing with STA research, and right now it's currently under development. We have right now 11 manuscripts that are under consideration. So the science plan itself was developed again 10 years ago in 2013, and we revised it in 2018. It specifies, it's basically specified in the restoration strategies and is required by permit-related consent orders. Basically, the whole concept of the science plan is to understand how these constructed wetlands work to remove phosphorus. And given that understanding, that will provide us some information on how to design, operate, and manage these systems in the future, especially to maintain over years. So there are 6 areas of investigation that we are looking at, dealing with 6 key questions. And as you can see, let's see if I've got the, okay. I don't see the, yeah, looking the laser pointer here. Control L, thank you. And there we go. I do want to show you, here's our conceptual model of the STAs. We have our FEB, which provides some flow regulation to the STAs. Then you have the operation of the STA with the inflows and outflows. You've got plants, the cattails, as we saw in Eric's presentation, and the SAB. And all we're trying to do is understand how the phosphorus is removed and retained within these areas using, again, going to the design and operation of FEBs, STAs, how to improve the vegetation and to maintain it, and looking at the internal loadings from the soils into the water column, and also all the biogeochemical and physical mechanisms that retain the phosphorus within the soils and keep it from flowing out. And finally, the role of fauna, which has been an interesting aspect of this whole study. So I'm not going into the completed studies to save some time. These have been presented in past years, but I do want to mention a couple of things. One is that the studies have long names, and because of that, development of operational guidance for flow equalization basin and STA regional operation, we call this the operation study. We have nicknames for them, so I'm going to be presenting the nicknames. I do want to point out the PASTA study. This is a study where we took a 100-acre cell, we removed the muck from the bottom to basically to lime rock, and it has been in place and operational for 15 years. And in those 15 years, the mean discharge of phosphorus has been less than 13 parts per billion, or less than or equal to 13 parts per billion, which reaches our mandated water quality effluent limits. So again, there's some other studies. Again, these are additional studies that were done recently, or studies completed. But I do want to mention the studies completed in the past year. We have the soil amendment, or the soil study, soil management study, had 2 aspects. One was to look at the potential for applying amendments to the soils, which, based on the literature review and estimates, is very expensive because of the broad areas of the STAs that would have to be amended. And there's uncertain effects downstream. So we basically went to look at other methods, and one of the ones that came up was essentially deep tilling, which we borrowed from another remediation study or remediation project, which was taking the soil and flipping it. And the concept there is that the agricultural soils, which are on the STAs, are pretty high in phosphorus. And if you flip it to the native soils, that phosphorus is lower, and you also get a lot of calcium, which tends to bind phosphorus a lot. So they did this in one cell and not in another. And so we were looking at the water in both cells over time as we put them into operation. And we looked at actually taking core samples in each one of these areas and found very promising results. The fluxes in the cores from the flipped area were less than those in the unflipped area. Field experiments often don't go the way you like them to. And for this particular system, the flows in the non-treated area versus the flipped area were different. The plants were different, and so we couldn't have a good comparison between the two. So the results are equivocal. So we ended that study. The SAB study, as again Eric pointed out, SAB can sometimes disappear, and they're very important. And there are reasons for that, mostly dealing with major storm events, et cetera. And we were trying to figure out, are there other reasons why they may disappear? And we had a study that looked at the SAB growth in these chambers called mesocosms. They're approximately 1 meter in size. And we looked at them under different conditions. And for 2 years, they looked at different loads, different soils, different water levels, different flows. And overall, the SABs didn't disappear. They were still there, and some of them were stressed, mostly at the higher loading levels, where we had abundance of SAB, but you get lower oxygen levels and lower light at the surface of the soils, which could lead to finally the reduction of the SABs. But again, that was never shown. We also had the tussock study. This actually, again, Eric pointed out the importance of tussocks, those floating wetlands that can create lots of damage in the STAs. And what we're looking at is two things. One is, why do tussocks occur? And we know that it's due to high water levels. Past land use can have an effect. And TP content in the soils also does have an effect. But so we also tried to produce a buoyancy model. As Eric pointed out, the cattail is very buoyant. And basically, if you've got good root structure, you're going to have a fair amount of buoyancy under high water levels, but if you have good root structure to hold it in, then the cattails are going to stay. Otherwise, they will float up. One of the other aspects, and this is probably more important in this particular study, was trying to use unmanned aerial vehicles to survey the areas for tussocks. And these UAVs, when we sent them out, they did find tussocks that were not seen in satellite imagery. So we can actually go into a little bit more remote areas in these cells to find those tussocks. And we can do this over time. And in the future, we've got some really good methodologies set up that can be done periodically. And then Eric's crews can go out and fix everything. And finally, the vertical advective transport. Groundwater is something that we've been considering. Is this a source of phosphorus? With that groundwater that pulls up into the soils, it can bring some phosphorus into the water column. And is that an important aspect of phosphorus in the water column, and does it reduce the retention of phosphorus in the STAs? Well, we went through and did a couple of things. One was to create phosphorus budgets and actually water budgets of cells close to the outflow, because that's where we're concerned about this. And because of the variability of all of this information, we couldn't find a signal. in these budgets. So we tried a simple tank and series model, and again looked at the sensitivity analysis using adding in this advective transport or the groundwater flows at different levels of phosphorus concentration, and again found very little impact of these of the phosphorus and the water going into those STAs from the soils, from the groundwater, affecting the phosphorus concentrations. Then basically all of the other biogeochemical processes are greater than these advective forms. So again, that was kind of an equivocal finding. So I wanted to real quickly go over the current studies that we have, these 9 studies, which is the bulk of this presentation. Again, because of time, I probably won't go through every aspect of them, but I will point out some of the highlights, either objectives, results, or status, or just talk about the pictures. And this one, I do want to talk about the picture. In the fauna study, there are a couple of things that we do know. We've got a lot of fish, which was the focus of most of the study, and those fish can affect the phosphorus in the water column either through excretion or through bioturbation, where they stir up the soils. And we do know that the large fish are the ones that really do stir up the soils. And some of again, it's basically species specific, and there are certain species, such as the sailfin catfish, that are very good at stirring up soils. And this particular photo shows that in terms of these particular these enclosures, which have 1, 2, or 0 fish. And you can see that there's quite a difference between the water quality when you have 1 fish, 2 fish, or no fish. And so we do know that they do have an effect. However, because the small fish are a greater density and they also produce a lot more excretion, they actually produce more effect of the water quality in the STAs than do the bioturbation from the larger fish, which tends to be very specific in terms of particular areas. So we can, fix the bioturbation essentially by selective fishing in different areas, I think, is one idea. And but in terms of the small fish, well, we'll have to figure that out. Here's another very interesting study. This is very CSI or FBI. One of the major triumvirate of species of plants that affect phosphorus is periphyton. These are the small plants, the algae, the fungi, the bacteria that all come together that can really change the phosphorus components through essentially degrading a lot of the organics and absorbing a lot of the phosphorus. And we wanted to try to estimate the various processes of growth, senescence, et cetera, for these particular species. And we find that one of the best ways to do that might be using DNA. So we've got these what we call metagenomic studies to first identify the usual suspects, which include, again, the various types of algae, fungi, et cetera, which was very successful in our pilot study. And also in describing what genes are turned on, which is another piece of this, to see what the organisms are doing. And one of the things that we did see is for the SAB region, there's greater expression of P metabolism genes, so they're doing things with phosphorus. In the EAB regions, there are genes related to P limitations. This is probably more dealing with the enzymes that break down organic material that can be used. The phosphorus can be removed and can be uptaken by the these nutrients by the different plants in periphyton. But anyway, they did find a lot of interesting information in the different places where you have the organisms. And we're actually ongoing a metagenomic study that's going to look at this over time for the next year. water year 2018 in the L8 FEB, the discharge concentration of phosphorus was greater than what came in. So this started this particular study, which was to ask the question, where is that phosphorus coming from? So first of all, we looked at groundwater and we looked at runoff, and neither of those had significant impact. Then we looked at the large inflows that do occur because, again, this is what the FEBs do. They take in large inflows to essentially reduce the impact on the STAs during storms. And we did find that those loads contribute a significant amount of phosphorus into the L8 FEB, but they also stir up a lot of the sediments, creating a fair amount of phosphorus and turbidity. However, this turbidity over a couple of weeks essentially settles out and the phosphorus decreases. So the operation of the L8 which is typical, is you pull in a lot of water, you store it for a while before you let it go out, and that will reduce the amount of phosphorus in the concentration going out. And since 2018, we haven't seen that concern of higher phosphorus concentration in the outflow than the inflow. So the biomarker study, this is actually an interesting study, similar in ways to the metagenomic study, in that they're trying to identify the different organic markers that can show them where's all this material, how's it being used up, and where's it going and coming from. And what they did find, they actually did a study where they took some of the vegetation and created these small litter bags, kind of like tea bags. And they're actually looking at the degradation of that material, and at different times during the experiment, they would actually put this into water and see what they could extract in terms of the organic materials. And that's kind of one of the ongoing things with this particular study. What they did also show, they looked at the inflow of the waters, the organics, and that all of that, and found that one of a very important aspect that had not been looked at very closely is the effect of photodegradation, in other words, sunlight, in that the organic material coming in is being degraded into smaller particles that can then, or smaller organic materials, most of that being in the dissolved form, that can then be mineralized or uptaken by the periphyton. And again, that's kind of an interesting story in that we do have areas, of course, with large areas where the water is fairly visible, and especially in the SAV regions, and that material is getting degraded by sunlight. So interesting set of studies. This particular study is about completed. We've still got a few analyses to do, and there will be a final report, of course. The P-dynamic study, this one is looking at the different flowways that are underperforming and comparing those to flowways that are well performing, using methods that were developed in the PFlux study that was reported a number of years ago. And right now we're kind of in the middle of this, but what I wanted to point out was they did a historical analysis, which is very important, and found the underperformance basically was related to all of the disturbances that occur in the STAs, dry out, reflood events, lost and damaged vegetation, construction activities, and high phosphorus loading rates. That's the bulk of where we are getting the underperformance, at least in terms of the historical data. And now they're looking at these particular sets, looking at essentially no flow or low flow and high flow conditions in both the wet and dry season. And these flowing conditions, they do see some things that are very consistent with a lot of what we have already learned, in that the water column, you've got under no flow conditions, you have a lot of particulate phosphorus. You also have higher concentration of phosphorus during no-flow conditions than during flow conditions. And we also see that the TP patterns are primarily dictated by what's coming into in the inflow in terms of SRP, which is your soluble reactive phosphorus. So this study is continuing on and will continue on for the next year, sampling in different areas as we can. The Marl study is another interesting aspect. Dealing mostly in the SAV regions, Marl is essentially calcium carbonate that has settled out, and it's a chemical effect of photosynthesis in the water column, which essentially changes the pH and causes the calcium carbonate to settle out, but it also tends to pull phosphorus with it. This material is very flocculent. It's easily resuspended for the most part. I've gone out there, and when fish run through it, you get these big plumes of this material into the water column. And so it's easily resuspended. So the question here was to determine, is there a way to consolidate it that would make it more permanent and would remain that phosphorus stored would remain in the soils? And they looked at two aspects. One, of course, was essentially drying and reflooding. The drying does consolidate it, but you reflood it after a while, it goes back to where it was before. If you consolidate it with some organic material, the organic material that they thought would actually have some of the microbes in it and could be very sticky, that could actually stick some of the stuff together like a glue. They tried that, and it wasn't going to work so it was ineffective. So they're still looking at some of the P-flux potentials after consolidation and looking forward to that. That's almost completed as well, at least this phase of it. One of the things that we haven't looked at is the different plant communities and how well they essentially remove phosphorus from one another. We've had a lot of information and some thoughts in this, and we know what the major communities are. And what we wanted to do is go out in areas and to look at the information or look at the phosphorus concentrations in different ecotopes or communities. This included mixed Chara, Naiad, Typha, and bare soils. And as you can see here, the phosphorus in the Chara bud area tended to be consistently lower than the others, though that we're still working on the significance, and that's why we're going into another year of sampling, is that there is a consistency, but it's not statistically significant. So we're hoping to get that this year. So a couple of the interesting things, again, that we've seen in other aspects of this research are the increased outflow and our water depth reduces the phosphorus concentration. And this probably is occurring because you're getting better mixing of the water throughout the STA area. So you're getting the advantages of certain areas that are really soaking up the phosphorus for us and getting that to pull down the phosphorus overall. And we continue this sampling through next year. So another aspect that we're trying to work toward is looking at the effect of flow on mixing. And this is where this landscape study comes into effect. And what we have is we've developed these long flumes to provide a little bit more control of all of the different environmental factors so that we get some really good results. And we built these two flumes. One is a straight flume and one is a V-shaped flume. And this V-shaped flume is actually of interest because we put water in at the top, and as it moves down due to the force of the water coming through, it slows down because you're getting larger and larger areas. And that will give us an idea of looking at flows versus mixing. And we'll add some plants in here and hopefully different densities and different water levels to see how that mixing occurs. The idea is to provide some more information for operations of how best to operate the flows and discharge to the STAs to get us optimal mixing of the material and hopefully optimal phosphorus retention. So how do we pull this all together? This is my study, the data integration study, and we're trying to develop a comprehensive description of the phosphorus dynamics and also provide some information to provide a guidance document for the managers and again, for people like Eric, who needs to go out and make decisions on what to do out there in the different flowways. So we've done a lot of reviews of materials, both the data and the literature, and we're actually currently working on just biogeochemical models. In this case, these models give us a sense of what's going on there. I hesitate to say they're predictive. We'll have some predictive ability, but I look at it more in terms of what they suggest is the more important flows and fluxes throughout the system that we should really focus on. And this will help us to move forward and hopefully give us some better information on what things we can do in these particular STAs. So here's where we are. The original studies in gold here are complete. There were 9 original studies. Then we had a number that were created and moved forward. We have a lot that were completed a number were completed in 2022, as shown here, and then we've got a lot that are planning to be completed this year. And when I report next year, which will probably be on the eve of my retirement, I hope to get as much of this information together and probably have a little bit better presentation that looks at what are the things that we've really learned from all of this research and how that helps us in terms of managing the whole system. Thank you so much.
Thank you so much, Tom. That was a good overview. And you were actually not far off of the mark. You did very well in getting all that done. This next presentation is done by Ms. Lucinade Dadrian. She's the project manager and the section administrator in the Engineering and Construction Bureau. And her presentation will deal with restoration strategies in engineering and construction.
Thank you. So good morning. Always great to come to this long-term meeting to provide updates on where we're at. The staff works very hard to get these projects to fruition. So as you can see, this is the main graphic that we have. And we are working through these projects as we go through, and the status includes the last 3 projects in construction, including the expansion number 2 of One West, the last segment of the Bowles Canal G341 conveyance improvements, as well as C139 FEB. So we have a project in each flowway, east, west, and central. So the first project that I'll provide an update on is expansion number 2. This is a 6,500 acre STA. It connects the STA One West through a conveyance channel and goes south and discharging to the south. So this is a very large project, over $214 million. Takes the inflows from 5A and C51 West into STA 1 West and outflow to Conservation Area 1. So previously we completed the underground piping that connects the 1 West to the inflow pump station. The STA and connector canal is one contract and it is 90% complete. The inflow pump stations are 60%, as well as the outflow pump station. Here are some pictures of the north inflow canal and levee on the left, and the northern section of the concrete conveyance canal to the right, just south of G310, or north of G310. I got that wrong, south of G310, sorry. All right, here are some pictures. These are interesting pictures of the inflow pump stations. Like I said, G780 is at the top end, connecting 1 West to the concrete lined canal. Previously, if you can see the red cursor, we did the underground piping to connect to the channel, the concrete channel. And on the right is the inflow channel from the downstream end of the concrete channel going into the STA. And that project was awarded around 76 million. And this next one, the outflow, also was around 38 million. It lifts the water from the outflow canal and delivers it to the Water Conservation Area 1. You can see on the left the pipe gallery that is being laid out for the concrete pour. And then on the right is more of an aerial overview where the L15 is to the left. So moving on to the central flowway, we have the G341 related conveyance improvements that we call Bowles East Canal that goes from the Hillsborough to the North New River. We've completed 4 segments made up of a lot of work. So the last segment, segment 5, is over 1 mile and includes 2 bridges, the Star Farms Bridge as well as Kennedy Farms Bridge. And on the left, we have a picture, well, both pictures are of the Star Farm Bridge. We're placing the piles on the left, and then you can see the beam slab placement on the right, as well as the canal. You can already see that it's been widened for the cross-section required for the full canal. Here's another aerial overview of the widened areas where we have the ditch to the left and the canal in the middle. Moving on to the Western Basin, we have the C-139 FEB, located south of the Deer Fence and to the west of L3. This project is overall, it's about 73% complete. The pump station is around 49%, and G551, which is the outflow, is about 100% complete with its concrete work. We have a lot of land leveling in this project, and that's about 86% complete. Levee construction, 74%, and canal construction, around 90%. We are on target to meet a substantial completion in July of this year, and we had a 60-day contract extension for a change order that expands the southeast levee and adds another 1,000 acre-feet of storage. So not sure if this is going to work, but this is an aerial video. Kind of shows, you know, it looks small on a slide, but, you know, it's pretty big in regards to what we're actually building out there. So I thought this was a neat view of what's happening. Now we're looking north, that's Deer Fence. That's northeast where the pump station is, the outflow. And we're looking, that's the training berm. And if I got something wrong, I'm sorry. Close enough. But really, really neat to be able to see. This is just a Google Earth fly-in and shows you how much work has happened to date. So again, some pictures. This is the pump station on the left and the pump housing being installed, and then concrete, the rebar around it, and concrete will be poured in place. So this is the outflow structure. I mentioned the concrete was 100% complete. We are still doing the backfill of the levee construction to tie it into the levee. Pretty close. So along with restoration strategies, construction projects, we also have some refurbishment projects. So the last one that we have to complete at this time is for STA2. And the work for the leveling is complete, and we're in planting phase with the vegetation management group. And so the 3 boxes that show 1, 2, and 3 are the different pictures. And that planting is 70% underway or completed. Looks pretty good. Let's see. And then the box, the larger box on the left, again, that regrading is complete and planting is underway, and we're about 10% completion on that. So in addition to the regrading, there were cell plugs as part of the contract. There were 37. The contractor completed 15. 22 plugs were removed from this contract. We are looking for support from the field station. Our great construction crew through the field station will be building plugs in cell 3 as well as in cell 2. So in cell 3, they're reconstructing 49 plugs, and then in cell 2, they'll do 11 of the remaining 22 in the appropriate locations to not see an impact. We did bid out the material that's required to build these plugs, and that's around $4 million. That went to February governing board, and pretty soon we will be mobilizing field station staff to go out and start the construction. So this is just a snapshot in time and where we're at with completing projects. As you can see, expansion 2, the bowls, and 139 are our last projects to complete in construction. We're pretty close to finalizing all this work. And thank you for allowing me to present.
Thank you so much, Lisa. So we see a lot of work has been done. And like I said at the beginning, we're rapidly coming to a close to restoration strategies, the construction aspects. So this next presentation is going to address some of the nutrient source control programs. We have Yachao Wang and Steve Sarley, who are going to present on South Florida Water Management Southern Everglades. It's a nutrient source control program update, and I welcome you, Dr. Wang. Yeah.
Okay, good morning. Thank you, Robert, for your introduction. Good morning. My name is Youchao Wang, and I'm a lead engineer in the Everglades and Estuary Protection Bureau. So today, my colleague Steve and I will present the update on the nutrient source control program for the Everglades protection area tributary basins. So source controls for this presentation are the activities or projects to reduce phosphorus in the runoff before it discharges to the Everglades, to the stormwater treatment facilities or receiving water bodies. So a typical example of the source control is best management practices or BMPs. This map shows the tributary basins to the Everglades. So the green area, the EA and the C1, C9 basin, discharge to the stormwater treatment areas, and all the brown area can discharge to the Everglades directly. So this slide shows how the long-term plan and the restoration strategy supplement the mandatory 1994 Everglades Forever Act by providing funds for additional projects and supplement and describing comprehensive strategies. So the goal of the 2003 long-term plan is to maintain and improve the water quality benefits of source controls by identifying cost-effective opportunities and working in partnership with the landowners and municipalities. Today's update will describe the source control activities in the EAA and Sevan basins, show the location in the map here, and where the source controls are implemented and the mandatory Chapter 4063. And for the other tributary basins shown in the brown area, source controls are implemented with the combination of the source control and the cooperative effort, and ultimately rely on the completion of the comprehensive Everglades restoration plan or sub-projects. Let's start a review the water year 2022 water quality by the tributary basins. So this table presents the tributary basins, the receiving water body, water year 2022 TP load, and also the TP flow weight mean concentration. So the tributary basins are sorted based on the TP load from the largest to the smallest. So as we can see in the table, the EA basin and the Sevan basin are the two largest tributary basins to the Everglades. We will provide a quick summary and update for each basin, except for the C111 basin, which is not part of the long-term plan. And more detail is provided in the 2023 South Florida environmental report. So as shown in the previous table, the EA basin is the largest tributary basins to the Everglades. So the source control program for the EA basin includes the elements for the basin as a whole, the basin water quality compliance, and also for each permittee, we call farmer level compliance, research and demonstration projects, and also include the sub-regional source control projects, primarily in the S5A sub-basin. So we will provide more detail in the next 4 slides. This figure presents the EA basin annual water quality compliance with the 25% TP load reduction requirement. So in this figure, the green bar represents the measured TP load for each year, and the yellow diamond represents the TP load target. So the TP load target represents the 25% TP load reduction for each year, and also the red diamond represents the TP load limit for each year. So as the target and the limit are calculated based on the rainfall data for each year, so you can see the target and the limit are varied based on the rainfall for each year. And so the EA basin annual compliance method is to compare the measured TP load with the target and the limit. So if the bar below the target, the basin is in compliance. If the bar above the target for 3 consecutive years or above the limit for any single year, the basin is out of compliance. So far, the basin is in compliance since the program started in 1996 with the long-term TP load reduction 57%, and for water year 2022, the TP load reduction is 66%. For the EA basin permit level compliance in 2022, the district staff will focus on the permit renewal as the permit expires every 5 years. So works of the district permit include the best management practice plan. So for the or called BMP plan. So the BMP plan, which means implementing the nutrient management, the water management, and particular matter and sediment controls. So this picture show as an example for the BMP implemented in the farmer level for landowners. So stepping into the research and demonstration project, so the Everglades Forever Act requires a comprehensive program of the research, field testing, and implementation of the BMPs. So the current 5-year EA EPT master research permit was issued in September 2020. And this research, the goal is to evaluate the performance between the EA farmer basins with the similar BMPs. So 3 pairs of the 6 farmers for this research project was selected. So the farmers are shown in the map in the slide. So this project, this research is a 5-year project. So each year they have an interim annual report. So the second interim annual report is completed in July 2022. And at the end of the project, there will be a final report. So more detail will be in the final report. This slide shows the sub-regional source control project. The sub-regional source control project is to supplement the existing regulatory BMP programs. As in recognize, the current existing BMP program is successful. The primary intent of the sub-regional source control project is focus on the ES S5A subbasin, also located in the eastern flow path. So currently we have 2 source control projects under consideration. So the first one, the location is upstream of the STI-1 east and west in the West Palm Beach Canal. The second project we are looking is for the East Beach Water Control District water quality improvement. So the project will located just upstream of the East Beach Pump Station 3 on the West Palm Beach Canal. Moving to the Swan-Sanan Basin, so similar to the EA Basin, the Swan-Sanan Basin also requires the source control program, is a mandated program through the Chapter 4063. So the program includes the basin level water quality compliance, but unlike the EAA, the Swan-Sanan Basin not require the permittee monitoring, which means the permittee level compliance. But the district has established the sub-basin monitoring and the upstream monitoring network. So like the upstream monitoring is shown like a U mark in the map on the left. So the upstream data will be used for the critical project or critical identification for the site visit in the Swan-Sanan Basin. Similar to the EA, this figure represents the Swan-Sanan Basin level annual compliance with the goal. The requirement is the Swan-Sanan Basin TP load at or below the historical level. Similarly, the bar represents the measured TP load, and the yellow diamond represents the basin target. The red diamond represents the basin limit. So the compliance also compare the measured TP load with the target and the limit. So if the bar below the target, the basin is in compliance, we can see. And if the bar above the target for 3 consecutive years or the base or above the limit in any single year, the basin is out of compliance. So as you can see, here the orange bar represents the basin out of compliance, and the green bar represents the basin in compliance. Just note in the 2018, the limit is very high, it's out of scale. So as we can see, the Sevan-Sanan basin is also in compliance since what year, 2010, for the last 13 years. Now I completed the update for the EA and the Sevan-Sanan basins, and my colleague Steve will continue provide the update for the other tributary basins. Thank you.
Thank you, Yo-Chao. I'm going to cover 5 other basins that are tributary to the Everglades system. They either do discharge directly to the Everglades system or have the potential to. And I'm going to begin with what we're now calling the C51 West and Acme Basin. And for our purposes today, I'd like to really concentrate on the Acme Basin, which was addressed in the long-term plan back when it was written. The Acme Basin is the southern portion that you see here of this C51 West and Acme Basin discussion that we're going to have. And I'm going to kind of look at this as essentially a tale of 2 Acmes, if you will, borrow from Charles Dickens, for a couple different reasons. The first reason is that we subdivide the Acme Basin into 2 major subbasins, Acme Basin A, which is located north of Pearson Road. If you're familiar with that, Pearson Road runs pretty much directly east-west through the village of Wellington. Acme is the water control district, of course, for the village of Wellington. Acme Basin A lies to the north of that essentially divide area, divide road and canal, and is, as you probably know, essentially very residential and commercial. Probably all familiar with most of the village of Wellington, typical suburban residential community. South of the Pearson Road divide is Acme Basin B. Acme Basin B is a lot different than Acme Basin A in land use. It's a lot more agricultural, and as we probably all know, very equestrian. There's several really state-of-the-art equestrian training facilities in Acme Basin B. And of course, when we have equestrian presence, we're likely to have a higher phosphorus discharge. The other reason that I say a tale of 2 Acmes is because historically, we have, back when the long-term plan was written, Acme Basin B discharged directly to Water Conservation Area 1, to the refuge. The long-term plan called for completion of the SERP project, called the SERP Acme Basin B Diversion Project. With the completion of that project back in 2007, those discharges that formerly went untreated into the refuge from Acme Basin B were diverted into Acme Basin A, diverted to the north through several structures along Pearson Road, so that now all the discharges essentially from the Acme Basin, both from Acme Basin A and Acme Basin B, end up in the C51 West Canal for eventual treatment, either for treatment in STA1 East or to tide. So we essentially, with the completion of the diversion project, it essentially eliminated those untreated discharges to Water Conservation Area 1, with a possible small exception, which we'll get to shortly. With all that being said, then, within this area, within Acme and the village of Wellington, the district has issued several environmental resource permits, both to the Water Control District and to various HOAs within the village of Wellington that include conditions for BMPs. as well as the village also has an ordinance for livestock waste storage and works in coordination with FTAX in the implementation of that. There's also an extensive monitoring network throughout Acme, and that includes all the structures that discharge directly to the C-51 West Canal, as well as divide structures along Pearson Road between Acme Basin A and B, and several other upstream monitoring stations within Acme Basin B. I will say that additional sampling has recently implemented by the district in areas north of the C-51 West Canal as well, because in addition to Acme's discharges into the C-51 West, C-51 West Canal also receives discharges from several water control districts to the north of the C-51 West, which is this area, all this area here. Includes the village of Royal Palm Beach, Seminole Water Control District, Loxahatchee Groves. So the C-51 West Canal, when we look at what the C-51 West Canal discharges eventually in the STA-1 East, we have to consider that it's also taking in those discharges from the north. So based on with what I just said regarding the historical aspect of Acme, this figure depicts what Acme Basin B, prior to the completion of the diversion project in 2007, discharged as far as total phosphorus directly into the refuge. So we can see all those discharges from 2007 going back through the period of record. And we see one little blip in 2013. I'll explain that. When I said that all of Acme Basin B's discharges are diverted to the north, there is an exception when the village of Wellington undergoes what's known as an emergency flood condition. The village, Acme, still has the potential through one remaining pump station, to discharge directly to the refuge. That did occur in water year 2013, when Wellington received actually in excess of the 100-year storm event as far as rainfall, actually well exceeded the 100-year storm event. I believe they received about 20 inches of rain in about a day and a half. So back in that, as a result of that storm, Acme was forced to discharge that small little blip there you see in 2013. Since then, as you see, no more discharges directly to the refuge. So this is current from 2008 onward. These are discharges from the C-51 West Canal into STA-1 East. So we see our loads are a bit higher than what was formerly discharged into the refuge, but we have to take into account that these discharges include all those areas to the north. And this is treated in the STA, whereas previously Acme Basin B's discharges, as I said, were discharged untreated into the refuge. So that was the completion of the diversion project back 15, 16 years ago now. So we're in a much better position as far as that goes. The next basin I'm going to look at is the Feeder Canal Basin. This is a western basin. This is an agricultural basin. Once again, we divide this whole basin into two subbasins. The North Feeder Subbasin, which is essentially, it's on the east side of this figure. We have a few landowners in the North Feeder. They're required through their environmental resource permits to implement best management practices and water quality monitoring. Also, there's two voluntary FAV tilling projects ongoing in that basin. And then to the west of North Feeder is the West Feeder Subbasin, about 32 landowners in this basin. And they're encouraged to enroll in the FTAX voluntary program for BMPs. This basin, the long-term plan relied on the completion of the SERP Big Cypress L28 interceptor modification, which has essentially been incorporated into the Western Everglades Restoration Project. So this basin is one of two basins that rely on completion of WERP. This figure, we see the concentrations discharged from the feeder canal basin through the S190 structure. This includes all the discharges from the north feeder as well as the west feeder combined. So we see here that water year 2022, we were at about 125 parts per billion on the concentrations here. So that's the feeder canal basin as a whole. We also have data on the north feeder. The north feeder historically has been more problematic as far as phosphorus concentrations. And you can see here, the blue line is the 5-year rolling average, and with the red squares, the phosphorus total phosphorus flow weighted mean concentrations. So we see here that the north feeders, water year 2022, contributed about 250 parts per billion. So you can see this is historically, not just in water year 2022, but historically been the more problematic of those two subbasins. Next basin we're going to look at is located a little bit to the east and kind of south of the feeder. It's another ag basin, agricultural basin, CL28 basin. Within this basin, we have one landowner in the north that has an environmental resource permit. It's citrus growers, Southern Gardens Groves. They're located in what we call the C-139 Annex. They're required through their environmental resource permit to implement BMPs. Of course, the C-139 FEB is located geographically within this basin, but it's really treating stormwater runoff from the C-139 to the north. Other projects in this basin include the Sam Jones Abiaki Prairie Restoration, and like the feeder canal basin, this basin relies on completion of the Western Everglades Restoration Project, or WERP. And looking at concentrations here, once again, we're looking at flow weighted mean concentrations here as opposed to load. And we see for water year 2022, we were pretty much about average of the period of record, so about 70 parts per billion on the phosphorus concentrations. All right, now we're going to move to populated Broward County. Suburban Broward County, C51 West Basin, located pretty much west of Fort Lauderdale. It's bordered on the west by water conservation areas, and this includes, the C11 West Basin includes several water control districts, including South Broward Drainage District, Central Broward Drainage District, and North New River Drainage Water Control District. ERPs issued to these water control districts include, once again, conditions for best management practices, as well as optimized detention and runoff and water quality monitoring, especially with South Broward Drainage District. They have very specific requirements in their ERP for optimizing detention prior to discharge into the C11 West Canal. Discharges from the C11 West Canal occur through the S9 and S9A structures. And this basin includes the SERP project, the Broward County Water Preserve Area. This project consists of 2 impoundments, a wetland buffer, intended to reduce discharges from the basin while maintaining flood control. Looking at this figure, C11 West Basin historically has had, pretty darn good water quality. Over the period of record, flow weighted mean concentrations have varied from about 12 or 13 parts per billion to about 30 parts per billion. We see in water year 2022, we were about right in there with, looks like about 13 parts per billion of phosphorus concentration as measured at the S9 and S9A structures. Finally, I want to talk about North New River, North Springs Improvement District Basin, NSID Basin. The NSID basin, once again, this is a basin in populated Broward County. Actually, the northwest corner of populated Broward County borders the Hillsborough Canal borders this basin in the north, running diagonally here. This basin includes the cities of Parkland, portions of Coral Springs, mostly residential, commercial, kind of typical suburban situation. Environmental resource permits issued to NSID include conditions requiring BMP implementation, as well as water quality monitoring. And also, very critically, NSID's ERP includes phosphorus load limits for discharge to Water Conservation Area 2A, if and when it does occur. And we'll see here shortly that it does not occur very often. Long-term plan project here included the completion of the SERP Hillsborough 1 site impoundment. This project is minimally underway. It's still awaiting congressional authorization before moving forward. Pretty much only utility relocations have occurred on this project so far. But I will say that as we look at NSID, we have a couple things going on here. NSID generally is able to, let me go back one slide. Sorry. Let me go back one slide. NSID has 3 pump stations. The NSID 1 located here at the southwest corner of the basin. This pump station has the ability to discharge into the conservation area. It can also discharge to the L36 North or L36 South Canal. Those discharges end up tied, either through the C18 Canal to the south or through the Hillsborough Canal to the north. The NSID 2 structure, located here, this structure discharges only to the L36 North, with those discharges also ending up in the Hillsborough Canal and tied. In the last few years, NSID has added another pump station, NSID 3, to further assist them in not having to discharge to the water conservation area. So this pump station is located at the north end of the basin here, right along the Hillsborough Canal. And once again, those discharges also end up to tide. So only when NSI discharges through NSID 1 to the conservation area are those discharges end up in the Everglades system. We've worked with NSID a lot over the years in trying to eliminate this occurrence. And we see here that we've been pretty successful in doing that, working with them. This figure depicts TP load into the water conservation area from NSID 1. And if you look at the scale there on the left, you can see that the scale, the load is very low. I mean, we don't even get up to 1 metric ton of discharge. We did have a fairly significant occurrence in water year 2018 as a result of tropical storms and hurricanes, when NSID was forced, due to flood control within that basin, to discharge to the conservation area. But even then, you can see that as far as magnitude goes, we're looking at barely over a half a ton of discharge. And since 2018, we had a little blip in 2019, an even smaller blip in 2021, and nothing in water year 2022 as far as discharge into the Everglades system. But once again, the basin has the potential. So those are the 5 basins that I wanted to cover today as far as other tributary basins. And I'm going to go ahead and summarize what Yo Chow and I have covered today. So Yo Chow, as he covered, the EAA basin, water year 2022, experienced a TP load reduction of 66%. With the water year 2022 results, the 27-year average annual TP load reduction for our program stands at 57%. For the C139 basin, water year 2022 remained in compliance. The measured runoff was below the target phosphorus level for TP load. Prior water year, we were a little above. Water year 2022, we got back down below. So we're in good shape there. As far as the other tributary basins that I covered during water year 2022, we have the voluntary and required BMP implementation based on environmental resource permits and agreements with the various water control districts, and have experienced some progress toward the completion of SERP projects, as well as WERP. Continued success and ongoing improvements to our source control program do rely on verification of BMP implementations, as well as continuing meaningful research and tracking program performance based on water quality data and basin-specific metrics. And Chapter 4 of the South Florida Environmental Report covers our program, Nutrient Source Control Program in the Southern Everglades. And thank you.
Thank you, Mr. Wang and Mr. Sarli. We're down to our last presentation, but it's not the least, of course. It's, we want to think that many of the public will really enjoy. We're going to hear about public use here at the South Florida Water Management District in the stormwater treatment areas. So I bring to you Mr. James Harbaugh. He's a recreation planner in the Land Resources Bureau, and he will take it from there. Thank you.
Feedback issues. Good morning. Okay. I'll just get right into this. Public use, recreation, basically interchangeable. And why do we have public use on the STA property or project areas? It's a statute. My notes are missing. Anyways, the statute basically says that we will have public use on the properties for recreation from the beginning. So that's why we have it in there. It's that important that it's put into a statute, basically. As long as it doesn't compromise the goal of the property or the project areas, then if it's compatible, then we will be having it. The 40E7 is the way, that's the public use rules that we implement in order to guide or control, or it's the rules that we can administer for the public use out there. My notes are missing. That's interesting. Anyways, we'll go through it with this. What type of recreation types do we have on the property? We have all this type of stuff. We have hiking out there and biking. The levees on the properties kind of lend themselves to, with a nice flat open area for hiking, biking, miles of accessible areas that for wildlife viewing. Wildlife viewing is a very popular thing on the property. Bird watching, photography, things of this nature. We do have day use areas. Excuse me. At our trailheads, we'll have like a picnic shelter within the property as well. So hikers and bikers, bird watchers, anybody can find these areas as well to take a break when they're out there, provide a little bit of shade. Some of the biggest use that we have on the properties are going to be the fishing and hunting. That recreation group has a lot of interest in this area as well. Both of them, the fishing and the hunting, are regulated by the FWC. The species, particularly hunting, we have 2 species that are out there that are harvested. Waterfowl, and also alligator. So that's what we have out there. Hiking, biking, the hunting, fishing, and then lots of public viewing for wildlife. So we have, what these groups here are the partnerships, our stakeholders that have a lot of interest, and they want to be out there, and we want to provide them areas to be out there. South Florida Water Management's responsibility is to provide the area, the guidance, the sideboards, if you will, as to where they can go, so that we're not compromising the project purpose. One of the biggest stakeholders we have, they are, particularly with the hunting and fishing seasons, they are the regulatory side of it. We give the area that they can hunt and where they can fish, and then they oversee the rest of it in terms of the rules and regulations that's consistent with their own, internally. Other groups that we have, the Audubon Society, we have, I think all of the STAs have at least some type of group that goes out there at least once or twice a year. And then we have Florida National Scenic Trail. They are a national organization with the USDS Forestry. Very well organized. They do the trail maintenance on the STA, signage, things of that nature. United Waterfowlers, obviously with the hunting, the waterfowl hunting is a big aspect out there, and they are one of the main stakeholders as well. I wanted to point out this group here, the South Florida Amateur Astronomers Association, excuse me, they go out to STA 3-4. In Florida, there's two areas that are considered dark skies, and one of them falls on the STAs. Basically, there's very little ambient light outsource, so you get a really good view of the night skies for photography, astronomy. They're usually out there for the new moon and the full moon. New moon being no moonlight even, so they get some really good pictures of the galaxy and some pretty cool stuff. I thought that was kind of a unique situation. This is a little more specific to some of the groups. We have, let's go, I guess I'll start in this corner here. STA 5-6 is a significant portion of the Florida National Scenic Trail. The trail originates down in the Big Cypress Basin, or actually Big Cypress Preserve, goes through the tribal properties and connects on the L3, I believe it is, or L1, and then traverses along the western edge of the property, and eventually ends up at Lake Okeechobee, connections of the various levees, L2, L1, one in the east, which is about 27 miles of levees that they're accessing through our properties. So without that section, the link would be completely lost. We've also just recently added 2 interim campsites in there. So when people are hiking through, they have a place to spend the night so that they don't have to do all 27 miles. This was put in there for our 40E7 rules, so they were able to do that. We don't provide them anything besides just the place. They have to bring their own water in. The trailhead does have some water, but it's non-potable. So this is kind of unique that it's the only place on the STA properties that we have the ability for the public to spend the night as they're hiking through. STA 5-6, I'm still there. This is a birding group that's out on it's an ADA compliant boardwalk. This boardwalk also dual purposes as a hunting platform for a person who may be in a chair. The railing has been cut down in places for viewing as well. It also has a ladder so that if somebody is hunting for waterfowl out there, they can have an assistant that can climb down into the water and retrieve waterfowl that they may have harvested. STA 2 is, this is kind of notable with the bird watchers. They really do enjoy their birding. A lot of people have a life list, and the life list includes flamingos, obviously, and we have some groups that we don't have a normal, regular cycle with tours out on there, but we do make special provisions, and the biologist with the rec program with land stewardship has gone out there with people to fulfill this need, this want from the public. All the STAs do have hiking and biking, and then it's going to be Friday through Monday on the weekends when people want to be out there. And I talked to one individual not too long ago. He has kind of come up with his own route, and it's approximately 50 miles that he does on his, it's a fat tire bike, gravel type of bike, not a road bike. And he, between our properties and some of the other the FWC properties, he's got a loop that he does. It's about 50 miles. So I wanted to continue talking with him and see what we can do to help expand some of this and make it well known. This is more concentrating on the hunting and the fishing on the STAs, whereas the other one would have been some more of the wildlife viewing. Waterfowl and alligator hunting is very, very desired on the property. It's some of the best hunting for waterfowl in the nation, I understand. And the people that are going out there are having fantastic days, so it's highly, highly, highly desired. And it's a point with, I spend a lot of time with FWC and the other partners on this as well. It has probably some of the most potential for impact upon the STAs in regards to its function. So it's highly regulated in that we are providing access points so that they go into the STA cells where we want them to go so that they would have the minimum amount of impact. Instead of going, so they don't traverse parallel to flow, we want them to go cross flow so we don't create short circuits. With the hunting, we have a couple different programs, or I'm gonna call them like specialty hunts. The FWC Youth Hunt Program is a youth hunt program that's specifically towards alligators on the STAs. FWC gives permits outside of the normal season for these individuals to learn how to hunt alligator. It's kind of like a learn to hunt program. STAs aren't the only properties they do this on, but this is the only property that they do alligators on that I know of. It's been very popular. This is last year, STA 1 East was open to alligator harvest by the governing board, and we had our first hunt on that last summer. Other specialty hunts, the Wounded Warriors, United Waterfowlers Association, they put together during the normal season program, it's not outside of the season, where they get some access into areas that would normally not be open to the public during that day, so opposite of the normal seasons. And they get into areas where they have lower pressure from other individuals, and then they are able to, they had a fantastic hunt this year. The federal waterfowl hunt, that is a federal season that the federal government has allowed outside of the normal season framework for harvesting for individuals. A lot of time, I don't know what the age cutoff is, I think it's 14, so that they can have an experience that they have mentors that go with them. It's a lot of volunteers. United Waterfowlers, again, is the one stakeholder that has a lot of invested interest in that. Fishing is real popular in the STAs as well. We don't have fishing in the project area, but it is within the STA boundary, if that makes any sense. So it's not going to be in the treatment cells. For example, over here in STA 3-4, that is the borrow pit. There's a boat launch there. It does allow for motorboats to be used in there, and it opens up, I think it's about 23 miles of canal access for motorboats. Other places that we have that, where you can put a boat in, it's going to be generally a carry-in type of situation where you can put a kayak or a canoe, or a rowboat if I suppose you want to carry something, but no motors are allowed in it. One, because of the location of the access is not suitable for a vehicle. Two, a lot of times it will have a situation like in the FAB, A1 FEB, where they do have a large area, but the topography of the area is kind of, I want to say not hazardous, but it's better off, it's better suited for kayaks and non-motorized boats. Both of those areas, the STA 3-4 and A1, have become really popular and fantastic fishing. Some instances I've heard of 100 fish days, and some big fish too. Over at STA 1 East and 1 West, we do have public use areas along the northern side of the property on the levees. We have a trailhead, for instance here, this is STA 1 East, where this is outside of the project area on the north side here, and individuals can access the levee and they can fish both of the distribution cells from the levee here within, guidance, don't go down beyond these areas to fish. And then it does connect over through the Loxahatchee over to STA 1 West, and between the two properties is about 6 miles of levee that is accessible for fishing. Hiking is allowed there as well, but there's quite a few people that do use this property for fishing. A little bit of a focus on the function versus public use. These are working properties. They're engineered restoration, and I wanted to point out that a lot of times the public has a misunderstanding that when we're talking about a restoration, this is not a restoration to like pre-civilization times, where we have areas that are altered, and we're using these areas to clean up the water with the most bang for the buck, considering the size of the properties and how much water is pushing through them. So it's, we have to remember that the focus on this, the eyes on the prize, is that it's for water quality. And with that, there's a lot of people that we have to work with in order to allow access into this areas. The projects are many going on inside of here. Veg management team is one that I deal with on a regular basis. I've mentioned already cross flow versus parallel flow. I've kind of come up with a way of, like when you look on this map, there's these reddish hashed lines here. If you were to enter into the cells from this levee going north or south, or perpendicular to that levee, you would be going with parallel flow, and that's so we do not allow that. And then these other cells, you can enter into there, and that's where we put our access points with for waterfowl hunting. And so then the veg management, that's one of the biggest things there, and then also the re-veg plans. I try to avoid areas where they're doing other vegetation management. We'll close that off to public access for hunting as well. Construction, there's a lot of construction going on in the last few years, and it's been probably some of the biggest impacts upon all of the access into these areas. For instance, here we have the G780 down in the north corner here, south corner, pardon me, completely closed this entire section of the cell for waterfowl hunting. Along the western edge over here, we have, there was intermittent different projects. It was just easiest to shut those down for access for the waterfowl hunters. It also works out well that that's shut off over there too, because this site is very, very sensitive to any access or any disturbance. So to prevent people from getting into there unintentionally, we just shut that down. We have haul route on this side. So by the time you're done with all the different types of construction activities, we have an access that comes in from the north, and these are the areas that you can have. So we have just this relatively small footprint area in where we have access into the larger property, but we do have access. So we're making it work. Other considerations are the field ops. They work on the properties Tuesday through Thursday. There's a lot of different structures out there, a lot of culverts. There's going to be some culvert projects coming up. So in order to work with that, we have the access Friday through Monday as a compromise, since they don't work Fridays, and Mondays are a low-use day from the public anyways. Land stewardship, again, I mentioned the biologist. We work with him closely on all the properties. We have already heard about stilts. We have areas where we have terns nesting over on STA 1 East. We have snail kites over at the FEB, A1 FEB. We have bald eagles, killdeer. So there are temporary closures on some of the areas due to these considerations. More construction. This construction was a big impact upon most of the STAs the last few years. The C-139 obviously is a huge project. And I mentioned earlier that the Florida National Scenic Trail has their trail that goes through here. We had to reroute it, worked with that group. They put up new signs and put up on their website. One of the biggest not problems I want to say, but one of the biggest challenges we have is communicating some of these changes that have occurred on the property to the special groups. Florida National Scenic Trail has done a great job of putting it on their website and also putting up the signage and taking care of it so that they can continue using it. That's a big kudos to them. Here's STA 2. A lot of construction going on in there this year. Here's the access point for like the waterfowl hunters. And the only sections that they can use is just this narrow area here because of haul routes, or there's no reason for them to go into some of these other areas because there's no access for anything for fishing or hunting that is suitable to their needs. I had to work with FWC to figure out these routes, and then communicate this information to the public is sometimes a challenge. We did not have a gator hunt in this property again this year because of all the different construction, and this little area here is basically the only area that there is any suitable habitat or areas to hunt for alligator, but there will be a youth hunt in there again this year. Moving forward, new SGAs coming into play, the A2. We have the expansion over at 1 West, the second expansion. All these things have recreation in mind. It's put into, this is basically a timeline from the beginning of the conceptual point of this is going to be, we're going to do this in this area, and then we introduce the recreational standards into the design phase. And then once that is all approved, and then you implement the construction and then go forward. The construction is completed. So just between these 2 points here is a great amount of time. Things sometimes got changed between here and there. So while we're doing some of the testing and the finalizations of the STA construction, recreation is reconsidered again. Now we kind of do like the finishing touches on it, if you will. What do we want to have? Where do we want to have it specifically? What type of structures do we want to have? Where the gate's going to be? Where the access point's going to be, et cetera, et cetera, et cetera. So I think of it as in the way of like a finishing construction. You are putting up the molding now. And then we continue with more, staff. We get input from the public. I could tell you long before we get to this phase here, the public has already got a lot of interest in this. They're already when they hear that there's something's going to be built, they start giving us input immediately. So we continue with the public input, and we look for what they want and how we can accommodate it if we can. And if we can accommodate it, we try to make it happen. Once the testing is all completed and the STA is deemed completed, and it's functioning, and we have been operating, then we go to the governing board and we get approval from the governing board for recreational opportunities on the property. This period of time, could be 10 years, could be 15 years. It's not an overnight process. But it's important that throughout the whole time that the public is involved and that we speak with them. Which brings me to public participation. We have quarterly rec forums where we get together the recreational groups and the stakeholders, not just for the STAs, but overall. We also have campgrounds and so forth, and so we cover a huge gamut of topics. But the STAs seems to be foremost a lot of times, especially with the hunting. And then if we have a property where we do have the access, we work with FWC and the rulemaking process, like for instance, the points, where we're going in off of a levee at a specific point into the cells in the project area. That's regulated by FWC. And in order to make these types of changes, if the public has something that doesn't make any sense, which oftentimes does happen just because rules don't make sense the same way in the project areas as they do in other properties, this is the place where this has to be done. It's the rule change that happens annually. There's a process that goes with it, and that is the best way for the public to get involved with this is to attend the rec forum meetings internally with us, and also to have input with the FWC. And with that, that is my contact information. That's good. Thank you.
Thank you so much, Mr. Harbaugh. All right, well, thank you so much. I think we've had some very good presentations. So what we're going to do now, in the last few minutes of this meeting, we want to open the door for any public comments. Now, if you're here and you want to make a public comment, there were cards that were on the sign-in table. But for those of you who are on Zoom, you'll see instructions on the screen. Just raise your hand and we'll acknowledge you, and you'll have 3 minutes to make your comments. I don't think we have any hands raised right now. And if there is no public comment, we'll prepare to close. But if any information you want further details on, like I said, the contact information for each presenter was at the end of the presentation. This presentation will be available online as well as on the Restoration Strategies page here at the district for any follow-up that anyone may have. So do we have any? Okay. Since we have no public comment, we can adjourn this meeting. I thank everybody for coming, and I really appreciate your participation and showing up. Right? Thanks so much. Right.